All right, so part 2 of the trapezoidal rule, continuing on that. So let's think about this for a second. Here's the rule, I think. Was this the rule? This is the rule. Here's the rule. And here we want to approximate this integral using the trapezoid rule. So what is this saying? This is saying we want the area under that function, whatever that function is. This is the function, right? From x equals 0 to x equals 2. Okay? And that's the area enclosed by that and the x-axis. So let's just get a look at what this is going to look like. Maybe we'll take the calculator out and type this in. So we have 1 over 1 plus x cubed. And it says use a table here. So what we're going to want to do is we're going to set up a table with our x and our y values. And our lowest x value is going to be 0, and our highest x value is going to be 2. And it says that there are 4 trapezoids we're going to make. So let me just take a second. Let me pause this. Okay, so I went ahead and typed this function in. And the first thing I want to remember is this b minus a over n. Well, what does that mean? Well, it means that we're going from 0 to 2. We want to have n trapezoids, which is, well, I guess 4 trapezoids, right? We want to have 4 trapezoids. Well, that means that we need to have the trapezoids positioned like this. Now, this is easy for us to figure out in our head, but we're not able to always do that so simply. So sometimes we need to take these two numbers and subtract them, find out the distance, that's b minus a, and divide by the number of trapezoids. That gives you the 1/2. So every one of these trapezoids, right, it's 4 trapezoids. Then what is the height of each of them? With a height of 1/2. They're all having a height of 1/2. So let's just figure out what we need here. I guess what we need is we need these values on our table. So we want to know 1/2, 1, and 3/2. And we want to know the y values for all these things. So I'm going to go ahead and make a table. Let me show you how to make a table. It's important that you see this. So when you type your function in, so let's say you've done that. Pause it if you haven't. You're then going to go to second table set, and you're going to change your independent variable from auto to ask. Make sure it's on ask and hit enter. And once you've done that, you can go to second, and up here is graph or table, and you're going to get the table. And I think we're pretty comfortable with getting this. And now what you want to do is you want to type in those x values. And they're going to ask you the x values that they're saying. So 0 is the first x value. 0.25 is oh, sorry, that's a quarter. We want 0.5. And then it's going to be 1, and then it's going to be 1.5, and this will be 2. And those are all the values that we had from the table. So let's see if I can delete some of these. Perfect. So this is the table that we just made. This actually helped us a lot because we were just able to make a table without typing in all of the numbers. I can't grab it, so unfortunately I'm just going to have to copy it down. So we got 1, we got 0.942281, we got 0.70711, we got 0.47809, and we got 0.3 repeating, it looks like. So what I've done now is I've figured out what all these trapezoids are kind of looking like. So I know that I have this, basically I've got these trapezoids that kind of look like this. If this here is 1, I've got this, and then I've got 1. The 1/2 goes to 0.94, so it's like right around here. The 1 goes to 0.707, so that's probably somewhere around here. I'm just plotting the x's and y's, not doing a great job with it, but doing the best I can. 0.5 roughly, and then 0.3. So we're basically just trying to figure out these trapezoids here. Okay. And what we need to figure out is how do we use the trapezoid rule. So the trapezoid rule is going to shortcut things for us. It's saying to take the b minus a over n, right? So here's the b minus a over n, and multiply it by the 2. This is the 2 from the formula for a trapezoid, and this is the 1/2 from here. Okay, so you get those two options. Probably shouldn't have circled them both in green. And now we have 1/4. The 1/4 is what can come out of all of these trapezoids. And now what we need to do is we need to take some of these values. So these guys are doubled. Why is that? Because they share a side. So look at your trapezoid. These guys are a side of two different trapezoids, so we need those bases twice. So what we're going to do is we're going to take the first base by itself. So let's just talk about what numbers we're grabbing here. We're grabbing these numbers. These are the heights of the trapezoid, I guess, or the bases of the trapezoid, depending on how you look at it. 1 plus 2 times this value, which is 0.94281. Beautiful. 2 times this value, plus 2 times this value, 0.47809, plus this value does not get double counted, so that's 0.333. Okay? And then you just need to crunch those numbers and figure out what that comes out to. Okay? And I will do that now, so just hold on 1 second. All right, so my approximation came out to about 1.64726. So that's what I think the area under the curve is. And remember, this is an integral. So what I'm going to do is I'm actually going to take this right here, this integral. I'm going to figure out what the actual answer is for that. So let's just grab the calculator. This isn't something you need to know how to do right yet, but probably not a terrible thing for you to see. You can go to Math 9, and that will let you take the integral of something. And what you can do there is you can just type in the 0, you can see it exactly as it's written. And then this was y1, which is variables, y variables, y1, with respect to x. So we're just getting the actual area. So the actual area is 1.402, if we round to 3, 1.402. So this is the actual, and this is the approximate. Now, why did we actually get an area that was higher? Well, let's take a look at our graph for a second. If you look at your graph and you imagine yourself drawing, I'm some trouble. Usually these images drag. Okay, anyways. If you imagine yourselves drawing trapezoids in this, well, what would you think would happen? I mean, you get this curve that kind of looks like that, right? Okay, and we're going from 0 to 2, so we're from here to here. And if we just take this for a moment, we try to look at the trapezoids that would be drawn in here, wouldn't the trapezoids kind of go over the graph a little bit? It's hard to see it here. But when the graph is like this, the trapezoids go over the graph, right? So this is an overestimate for that reason. Because it's concave up, actually, it's an overestimate. If it was concave down, think about what that would mean. Would the trapezoids over or underestimate if it's concave down? And that's the trapezoid rule in a nutshell. So you are to try these two problems, page 315, number 89, number 90,